I'm a professor at Columbia University, and I'm in biophysics, and I specialize in electron microscopy, and specifically in application of image processing to recover structural information on biological molecules. Well, it's a way of looking at the structure of macromolecules in a particular way. You look at it with the electron microscope, and the molecules are embedded in vitreous ice. Vitreous ice is formed when when water is cooled very, very rapidly, and it's sort of a glass-like configuration of water, which has the advantage that it doesn't expand, so it doesn't form crystals. And in that kind of environment, molecules are unharmed by the rapid transition in temperature, so they're not being crushed. Right, so molecules are building blocks of life. In a cell we have many, many molecules, and life processes are formed by the interaction of all these molecules. And in order to understand how to do this, one needs to know the atomic composition, and actually the atomic structure, which means that one needs to know the position of every single atom. So only then one can understand how molecules interact with one another. So there are different ways of getting structural information. One has been long established, which is called X-ray crystallography. You know from your background what it is, okay? But the little kid doesn't know it. One way of finding out the position of every single atom in a molecule is by looking at a crystal of molecules. Molecules can be arranged in crystals in very high order, and in that case one can use X-rays. One shines X-rays on it, and one gets what's called this diffraction pattern. From the diffraction pattern one can infer the three-dimensional structure of the molecule. The big problem is that this method, which works wonderfully, cannot be applied to molecules that don't form crystals. You know, you try to get them in crystal formation and you don't get it. So there are 140,000 structures that have been determined by X-ray crystallography. They are all in the public data bank. But there are hundreds of thousands of structures that cannot be visualized because they cannot form crystals. And I'm talking about methods to get structures for those. So the whole idea was why do we need crystals? Why do we need crystals at all? You know, maybe we can get the information from images of single molecules that are simply swimming in water, and then are deeply frozen, and then they are in ice. So then all these molecules they're identical in structure, and they are in different orientations, random orientations. So I don't even have to tilt them in order to look at to find different views, because they have tilted themselves. Okay, so now we instead of tilting one individual molecules in all these different angles, we already have all the information. We just need to get it together, put it together, and it's a computational problem. It's a mathematical problem. Okay? The biggest problem is how to find these orientations, because the molecules have chosen to tilt themselves. we don't know into which angles. Okay, it changed it in major ways. The way I explain it is one is that I don't have to write review articles anymore because there's no pressure on this. Writing the review articles is a terrible thing to do. You know, it doesn't get you anything. You only think, you know, maybe if I write that one following an invitation, you get a little notch higher in your profile. And so I don't have to do this anymore. This is one big advantage. The other one is that I can finish sentences. I used to be interrupted very often. I don't get interrupted anymore, and that's a very big advantage. So aside from that, is obviously one gets many invitations. One is sort of in a different circle of people. One is able to approach people that are sort of they're considered high and really much higher than approachable by you. So I find this very very exciting. So I've met people not in my field who are just they have some kind of a celebrity position but they don't mind to be approached by the Nobel Prize winner. Okay? So this is one advantage. Well, I think it's an every country has its own way of awarding achievements, and this one is very well established. It has a very high prestige, and it's a wonderful way for a country to motivate scientists, give them awards for achievements, and also give signals to the society of what is good. You know, what are the good directions to take, and the fact that it is in different sections, categories, means that you really cover a very large range of activities that are important for society. So this is a very good thing, and so that you don't have a single one, but you really have prizes in all the different areas. Students have a lot of support here, and whenever I meet students, they are full of excitement. I think they have very good backing by the society. Later on, I think the positions are very sparse. They are almost forced to leave Spain, which is a very sad situation. And resources are minimal, really. In my own area of cryo-EM, I watched a struggle by one group, a very established group, to get an electron microscope which was really the state of the art, and it took years. And then in the end, they got a microscope which was not the real top one that they wanted, you know, because of some counting of pesos or euros. So it's really, I feel that there's a lot to do here in administration of resources in science. Spain simply has not kept up with the with countries like Germany, other European countries, the United States, and so on. Essentially by giving anecdotes on what the achievements of science were, and they are not. They are almost never in the short run. They are always in the long run. So you have to build up some kind of a potential. You have to build up resources, and then you get your work is published, and maybe 5 years, 10 years from then, there's going to be a fruit of this, and it can be fantastic. It can be a very big quantum leap. You cannot predict it. You really have to invest in it, and then have faith in the fact that it's going to bear fruit. The message would be maybe you, through your motivation and your energy and very hard work, you can get into a position where you can make decisions here that have an impact in society. You have to get into, maybe in politics, you have to get in leadership position in which you can have an influence in decision making. I think it's very clear from what we said that the importance of science communication at very early age. People should be educated in the importance of science and the way science works from early on. It could be middle school in terms of the United States education, and high school. So I've been put a lot of energy into trying to simplify the concepts so that I can get them across at very early age.